Hey there, welcome to yet another video on serverless. In our previous videos in the serverless series, we saw how we can build an serverless API connecting to various serverless databases like DynamoDB, MongoDB Atlas, and so on. In this video, we will develop an API using a different way. We will create a NestJS application connecting to a serverless Postgres, which is provided by Neon.Tech, and then we will publish this NestJS app in a serverless fashion using Serverless Framework version 3. So without wasting much time, let's get started. First, let us go ahead and create a serverless Postgres database using Neon.Tech. You can go to Neon.Tech service, sign in with the various options that are available like GitHub, Google, etc. So I am already signed in here. With sign in, you will get a free project with 10 branches, each branch supporting around 3 GB of storage. It will also provide you 3 compute endpoints, which is of 1 virtual CPU and 4 GB RAM. So once you are here, click on create a project. Give a name to your database. So let's say I will give a name to the project called Serverless PG NestJS. I will select Asia Pacific and click on create project. Once you do that, you will get the endpoint along with an option to download the .env file, which will provide the password. What we will do is we will copy this endpoint so that we can use it in our code. Next, let us go to our terminal and create a NestJS application. First, ensure that you have Nest CLI installed. You can follow the documentation on NestJS website. Download the npm package globally for the Nest CLI. I have it already installed. So let's create a new app. For that, we will use nest new and the name of our application. I will be selecting yarn. Okay, so this will take few minutes in order to get configured. I will pause the video and come back once this is done. Okay, so the boilerplate for our code is ready. So in order to get, we need to cd into the project, and to start the application, we can use yarn run start. So what we will do is I will open this application in Visual Studio Code. Okay, I think my spelling is wrong. Okay. Okay, I have my VS Code open here along with the boilerplate code. If you look into the package.json, it uses NestJS version 8, but the latest is 9. So let us upgrade it to the latest version. Okay, so while it is upgrading to the latest version, we will be using type ORM for connecting to the database. So let us go ahead and create the respective configuration parameters. So I'll just create a .env file. I will go back to the Neon dashboard, copy this endpoint, paste it here. So I will create various variables like pg host, pg user, pg pass, and pg database. Okay, so this is the endpoint. User is I'm Durgadas. This is the password, and the database is NeonDB. So I don't want to call it NeonDB, so we will create our own database. Okay, let's say we will create a database called YouTube YT serverless. Okay, so once we have this in place, let us go ahead and download the necessary npm libraries that we will use to communicate to the database. Okay, as you can see here, our previous yarn upgrade is done. If we look into package.json, it is now having the latest 9.x version. So let's install the type ORM library using yarn add @NestJS type ORM pg config and @nestconfig. This last two is needed for us to use the .env syntax and to make those environment variables available. Okay, so in addition to this, we will need some more libraries which we will install as in when we need it. Okay, so let's create this. At the same time, let's go ahead and clean up few of the auto-generated files. So we don't need these spec files as we would not be writing any unit tests. So while we bootstrap this application, it created an app module which brings in all the necessary modules that we define in our application together, an app controller and an app service. Okay, so we don't need app service and app controller, so we will delete this. Similarly, we will delete the respective references from our app module. All right, so here we will be creating APIs for our songs service. So basically we'll be able to create a song entry, find song entry and so on. So we will generate this for us using nestg resource song -- no spec. It will be a REST API and we want it to create CRUD endpoints. Okay, so as you can see here, it is creating the necessary files and it will also register this module into the app module. As you can see here, it has registered the song module within the app module. So we will go inside the generated files under the song folder. I don't want DTO for this example since I want to keep it very simple. We have entities which has song.entity.ts. We have song.controller. Okay, so we will delete this unused imports. Okay, so we will fix these errors in some time. So I'll be supporting only two endpoints here. One is create and another is get. The API will be made available at path songs plural. So I will go ahead and delete all the unused imports. All right. Similarly, in the song service, we will have different methods which will be invoked from the controller. All right. So next, since we have installed the necessary libraries, we need to create the type ORM configuration. For that, we will go into app module. Here we will register our type ORM module. Before that, we want to use .env. So we will configure that using config module for root, and we want this to be made available globally. So we will set is global to true. Similarly, we will set up type ORM module dot for root, and within options we will have to provide the connection details. Okay, so I will copy that from my file, which I already have it handy. Okay, so here, as you can see, I'm saying we want to use type Postgres, and we have various environment variables being set from the .env. It is configured with SSLs through. The auto load entities will load all the entities that are defined automatically, and synchronize through will ensure that it creates and keeps our entity definitions up to date with the database. This is not a recommended option for production, but it should suffice for this video. Okay, so once we have the type ORM configuration here, let us go ahead and create our entities. Entities is nothing but tables in our database language. So first we will annotate it with entity, and within this entity we will create the fields that we need. Okay, so in order to save time, I will just copy it from my file, and I will import all the necessary annotations from type ORM package. Okay, now what does this do is, it says that I have an ID field which is a primary key and it's generated. Along with that, I have few more fields which are defined with column annotation, which is nothing but a field in my table. Okay, so once we have this entity defined, we need to register this entity so that type ORM knows that this entity needs to be managed. So for that, we will go to song module, add imports, which is an array, and within this import we will use type ORM module dot for feature, which takes in an array, and within this array we will import the song entity that we just created. Once we have this song entity, let us use the repository class provided by NestJS and type ORM in order to communicate to the database. So as you can see, we have this controller which injects song service within its constructor. Similarly, what we will do is, we will go into the song service, define a constructor which will inject the repository. So for that, we can use the inject repository annotation, provide the song entity, private read only song repository, which is of type repository, and we can pass the generic type, that is song. So now if you see, this song repository is of type repository, which will be for the song entity. So now let us modify these methods to use this song repository. First, let us add async to both the methods. The create method will return a promise of type song, and similarly find all will return a promise of array of songs. Okay, so we will change the return to await this dot song repository dot create dot save, sorry, and pass the create song DTO. Okay, Since we don't have this create song DTO as we deleted, for simplicity, we will just use the song entity itself. Please look, this is not the best practice as it's always recommended to use a DTO which is kept separate from the entity so that we don't expose all the fields from the entity to the end users as part of the contract. But since this is only for demonstration perspective, we will use the entity as our contract as well. Okay. Similarly, we will change the find all to this dot song repository dot find, where if we don't pass anything, it will return an array of songs. All right, so we have this song service ready. Let's just go to the controller and fix the type. So this is of type song. We will make this both async and we will add await. All right, so let us go ahead and run this NestJS application in dev mode. As you can see in main.ts, it should start on port 3000. In order to start the NestJS application in dev mode, run yarn start :dev. Okay, so there are no compilation errors, but at the same time we see a problem connecting to the database wherein it's saying password authentication failed for user I am Durgadas. Okay, so let us go back to our .env. First thing is my username is in small case, and at the same time we don't have a database called YT serverless. Okay, so let's go to the Neon console. Let's go to settings, database. Let's delete the Neon database and create a new database with name YT-serverless. Okay, let's create. Also, if you look into these operations, you will see that if we don't use our database, it will suspend it. So the compute is suspended. So every time it receives a request, it will start back the operation. And creation of the instance takes around 4 seconds. Okay, so now we have YT serverless. So let's go ahead and try this again. Okay, as you can see now, we don't have any error communicating to the database. We see the Nest application is successfully started. If you go back to the dashboard and look into tables, we see that the song table is created along with the fields that we have defined. We can also go to the SQL editor and issue a command like select star from public schema song database. We can click on run. At this moment, it doesn't return anything because we don't have any records in our database. All right, so since our application is now up and running, let us issue and invoke the create and the get APIs to see if everything works fine as needed. So I will be using HTTP client within VS Code. I have already made videos earlier on how to use it. So I will reference the link to the video in the description. So I will create a file called API HTTP, declare a variable that is HTTP localhost :3000. I want to invoke a post API to this songs endpoint. I will be dealing it with JSON. So the content type will be application JSON. And I will paste the body for my API here. As we can see, I have name, XYZ, artist, etc. I have not specified the ID column as that would be generated automatically. I will click on send request. And as you can see, it has written T01 and it is success. Similarly, I will check out the get all API using songs endpoint, and invoking it returns an array with the details of the songs. Let me make another entry appending to. We'll make a send request, create it. Let's make a get request. And now the get response has both the songs in it. All right. So as of now, whatever we have done is local, right? And it is as part of the Nest app. We want to publish this in a serverless fashion. So in order to do that, we will be using the serverless framework. So in the root of your project, create serverless.yml file, and within the serverless.yml file, specify the various options. Here I'm saying that my service is called as NestJS Serverless PG. I will be using AWS as my cloud provider. The runtime would be NodeJS 16. The architecture will be ARM64. And in addition to that, other fields are defined like stage, region, memory, log retention, etc. If you notice here, I have specified the timeout as 15 seconds. The default, if you don't specify, is 6 seconds. And since the database is also serverless and when not in use, the compute is suspended, bringing it back will take around 4 seconds. And then creation of the NestJS app might take in few more seconds, which will exceed the default 6 seconds timeout. So in order to be safe, have it configured at either 10 seconds or more than 10 seconds. In the functions, we just have one API function. The handler is defined as lambda.handler within the dist folder. We don't have this yet and we will be creating it in some time. It will respond to an HTTP API event. For any method, it will just proxy it to the app. For this application, we will be using a couple of plugins. Serverless Jetpack, which efficiently packages the serverless application. Serverless Offline plugin, which will allow us to test our serverless lambda locally. Okay, so what we will do is, in order to make the NestJS application available as a lambda function, we will be using a plugin. Not a plugin actually, we will use an npm library called serverless-express, which will wrap up the NestJS app and make it available as a lambda function. Okay, so for that, let us install Vendia/serverless-express application library. Okay, along with this, we also need to make these two plugins library available. So we will install this in the dev dependency. For that, we will use yarn add -d, serverless jetpack and serverless offline. Okay, so we will delete this package log since we are using yarn. Okay, now let us go ahead and create this lambda handler. So go to your src, create a file called lambda.ts, and within this lambda.ts we need to expose a method called handler. As you can see here, lambda is the file name and handler should be the method name. So I will copy the snippet here. What we are doing is we are importing the necessary methods from serverless express. We are creating a variable called cache server. What does this do is, if the lambda is already instantiated and we make subsequent calls, we want it to make use of the cache server rather than instantiating it again and again. So what will happen is all the methods will be using a common server. So the first call will be little slower as there will be cold start, but the subsequent requests will be pretty fast. So within this handler, it takes in the event and context. If we don't have a cache server in place, that is, this is not instantiated, we will be creating a Nest app from the app module, which brings in all the necessary modules together. And then that app, once initialized, will be provided to the serverless express, which will wrap it up and return it back to the lambda context. Okay, so since now we have this in place, let us test this out using serverless offline. So for that, we will use a command serverless offline or SLS offline. Okay, one thing is, since it is pointing to the lambda.handler within dist, we need to build this application. So I will just delete this dist folder, issue a yarn build command, which will generate a production build, and it will have all the necessary files in the dist folder. Now I will issue SLS offline. Once we issue SLS offline, we see that the API is made available at this location, which is localhost 3000 and proxy. Proxy is nothing but whatever is our API path, so that we need to provide, and that will be then proxied to the express wrapper. Okay, so I go back to my API HTTP and I will make this XYZ3 and I'll click on send request. Before I click on send request, let us look at the Neon console. Okay, as we can see here, the compute is suspended. So the first call that we make will take some time. That is, it may take more than 6 seconds. So let's click on send request. As we can see, it is instantiating the NestJS app. We see that it took around 6.5 seconds and the API has returned the response. All the next calls will be pretty fast. If I click on send request for the get, you see it has returned within 72 milliseconds, 72 milliseconds, and so on. Similarly, I can also make call to my create again. Since it will be reusing the Nest app as part of the cached instance, this should also be pretty fast. As you can see, it has written within a second, and in this case in 216 milliseconds. Great. So we have our serverless API tested locally. Now let us deploy this into our AWS cloud account. In order to do so, you need to first configure your AWS using AWS configure command, and then on the prompt provide the access key and access secret. In my case, I already have it done. So once that is in place, just issue SLS deploy command. So this SLS deploy command will package this serverless application, create the corresponding CloudFormation template, and then create the necessary resources. In this case, it will create the API gateway service, the lambda function. It will configure the API gateway with the proxy URL, which will delegate it to the lambda. The database is the serverless Postgres service that is provided by Neon.Tech. Okay, so this CloudFormation script might take around 2 minutes to complete. So till this is done, I will pause this video. Okay, as you can see here, we have our service being deployed to AWS. We can check this out by going into our AWS account, going to the lambda, and you can see I have the function name NestJS serverless PG. The stage was dev and the function name was API. Within this, if I click on monitor, I'll be able to go to the CloudWatch logs. At this moment, we haven't made any invocation, so this would be blank. So let's go back to our VS Code, copy the URL of the deployed AWS function, go back to our REST client, update the host to point to the AWS, and let's call it AWS1, AWS artist 1, AWS something. Okay, and we'll make a call to this API with send request. As you can see, it's waiting and it's taking a while since this is the first time and there will be cold start. And as you can see, it has returned me back the response. Now the subsequent request will be pretty fast. As you can see, it has returned in less than 200 milliseconds, right? So we can go back to our AWS account. We can refresh the invocation. Okay, so let's do one thing. Let's go to lambda. We'll go to this application. We'll go to monitor. All right, okay. Not sure why it's not yet here. Though I can see certain durations. Okay, let's go to CloudWatch and see if there are corresponding log groups. Click on log groups. Okay, there is a log group here. We can see the log stream. And within the log stream, we will see various requests. As you can see, the first time the duration was 6850. It is because of the cold start, right? And the subsequent request was pretty fast. Okay, so as you can see here, we have our NestJS application deployed in a serverless fashion to AWS using Serverless Framework with Neon.Tech serverless Postgres database. If we go back here and run this SQL, we will see all the data entries that we have made. Okay, so to delete the entire service, we issue a SLS remove command, which would remove all the created resources from our AWS account. Okay, one bonus here is that with Neon.Tech Postgres service, we do get an option of branching. It works in a similar fashion to how the development process works in Git, wherein you have a particular branch and you can branch it out, which will give you a snapshot, and you can make your changes incrementally, and once satisfied, you can merge it to your main branch. The same principle can be applied with Neon.Tech database as well. So let us see how we can use it. So for that, we can go to the branches option. Let's say I want to branch out from this main branch. We did see that this main branch had a table called song and it had various entries. It already had records. I want to branch it out from this and I need to get all the data in my new branch because I want to make some changes or debug anything on that data. In order to do so, I can click on new branch. Okay, let's give a branch name called debug, or let's say feature 1. I want to branch it from the parent branch. We have two options, either create an endpoint or don't create an endpoint. Don't create endpoint would only have the snapshot of the data, which would act more like a backup. But in our case, we want it to give an endpoint so that we can configure that endpoint along with our application and make subsequent changes. Okay, so what we will do is, let's say create endpoint. It gives us a new endpoint here. Okay, so let's copy this endpoint. Let's go back to our application. In the .env, let's change the endpoint. And let's say we want to add a new field, which was not there in the main branch. Let's say I want to create a new field called year. Okay, let's say the year is a number. Okay, and I will annotate it with column. All right, so we will test this out using start:\dev. It says unable to connect to the database. Okay, it's because when we give just column, it becomes a non-nullable field, and since we already had records, since we branched it out, it already had records from the main branch, and those branch records did not have this field year. So what we will do is we will just pass an option called nullable to true. Okay, and we will do a start:\dev. Okay, as you can see, my application has started now. Okay, and we could pass this new year in our payload and click on send request. Okay, so for that, first let me change back the endpoint to localhost 3000 and click on send request. As you can see, the API has successfully invoked. If I go back now to my Neon database, I go to SQL editor. If I do a select star from public.song, this is against the main branch. Okay, it is taking time here since it is initializing it. We see that there is no column called year. Similarly, if I change it to feature 1 branch, and run this out, we see that we have all the records from the main branch, and in addition we will also have the new entry called with the field called here. Okay, so let's make another. So we did see that the year was null. It is because this field should be here and not song. So we'll make feature 1 name, and let's make this something, and we'll call send request. Now we can see there is year 1999. I go back, run this, and we see the new field in our feature 1 branch. If we go back to the main branch, run it, we don't see that field. So here you see that you can incrementally make changes using the power of Neon database, which supports the branching methodology similar to how you would use in your day-to-day development. All right, so that's all I wanted to share as part of this video. If this was helpful, then do subscribe to my channel, press the bell icon to stay up to date with all the videos that we make. I will see you in the next video. Until then, happy learning.